In this video, we're going to learn a little bit about chemical reactions, how they're written out, as well as how to balance them if needed. Here we have an example of how a chemical reaction can be written out. It could be written either entirely as symbols, as shown on the top right here, or in its word form on the bottom there. The arrow in the middle of the equation represents the reaction that happens. On the left side of the equation, we have the chemicals that we start off with, known as the reactants. These are the chemicals that are going to be mixed together to cause the reaction. And on the right side, we have are end products or just products, what we end up with after the reaction happens. For the work that we are going to be doing with chemical reactions, there's one important rule that we have to remember. That rule is known as the law of conservation of mass. And with respect to what we are looking at right here, the amount of the reactants that we start off with must be exactly the same as the amount of products as we get at the end. So for example, if we started off with 125 grams overall of reactants in the beginning, then if we were to weigh what we had after the reaction, we should have exactly 125 grams as well. Okay, let's take a look at some actual questions. We're now going to be just dealing with the symbol version of the reaction formulas. Now, as I said before, according to the law of conservation of mass, whatever we start off with needs to be the exact same amount as what we end up with. And right now with this formula shown here, we do not have that. I just drew that line down the middle to help separate the two sides for what we're about to do. Now, the hydrogens, the H's, you'll notice that there are two of them there, whereas on the right side, there's only a single one of them. And same thing with the chlorines. There are two chlorines on the left and only one on the right. This cannot happen. We can't have elements just mysteriously disappearing or appearing. Whatever we start off with needs to be exact same amount as what we end up with. So we're going to have to do something about that. And that's called balancing the equation. To balance the equation, we'll start off looking at the hydrogens on the left side right here. We have two hydrogens on the left side, and on the right side we have a single one. So in order to fix that, I'm going to make an extra copy of the hydrogen on the right side. I'll do that by dragging that down to create another one. So I've got my extra hydrogen, but I've also brought along an extra chlorine as well, because in the original compound, we have one hydrogen and one chlorine bonded together. We can't have a hydrogen just appearing by itself there. It needs to drag along a chlorine partner as well. This results in us having two hydrogens on the left and two hydrogens on the right. Moving on to the chlorines, we have two chlorines there. And because I created that extra HCl here, I now have two chlorines on the right side as well. Because we have the same number of elements on the left and right side, this formula is now considered to be balanced. On your assignment sheet, you'll notice that in front of each of these compounds, there is a line. That's for us to write down how many groups of each compound there is. So with the H2, there's only one of them, one group of the H2s, one group of the Cl2s, and two groups of the HCl's. Now, just like other parts of chemistry, we don't actually need to write the ones in front of the H2 and the Cl2. We often don't write ones in chemistry, so we can get rid of those right there. So the final answer is H2 plus Cl2 creates 2HCl, and that's finally a balanced equation. We can also do this question with just the symbols without writing the pictures of the atoms below if you don't want to take the extra time to write all those extra ones there. So if you want to solve this with just the symbols, I'll take a look at the left side with H2, and on the right side, I've only got one H there. So I'm going to have to create an extra H, which drags along a chlorine for the ride as well, since they are bound together. So I've got 2 hydrogens on the left and 2 hydrogens on the right. Then moving on to the chlorines, I've got 2 chlorines on the left and 2 chlorines on the right. This is now balanced. And then for the final answer, I only have one group of the H2, one group of the Cl2, and 2 groups of the HCl. So that would be my final answer there. Another example, K2O, also known as potassium oxide, breaks down into K plus O2, potassium and oxygen. I'm just going to separate the two sides right there, and then I'm going to look at the number of elements on both sides. So on the left side, we have 2 Ks, which I'll start off with, balancing, and on the right side, I only have a single K. So I'm going to have to create an extra one of those Ks. So now we have 2 Ks on the right side and 2 Ks on the left. Moving on to the oxygens, we have 1 on this side right here and 2 on this side over here. So I'm going to have to create an extra oxygen. And there we go. This now creates a problem with the potassiums, though, the Ks, because I had them balanced before with 2 and 2, but creating the extra oxygen dragged along an extra 2 Ks, so I'm going to have to create some more Ks over here to balance that out and bring it up to 4 Ks overall here. So now I've got 4 Ks here, 4 Ks here, 2 oxygens here, and 2 oxygens there. This formula is now balanced. So our final answer will be 2 of the K2Os, 4 of the Ks, and only a single one of the O2 pair there. So our final answer is 2K2O creates 4K plus O2. I'm going to do that one more time, this time with the symbols instead of the pictures, in case you prefer it that way. On the left side, I see I have 2 potassiums and an oxygen. On the right side, I see I have 1 potassium and 2 oxygens. These runs are not balanced right now. Starting off with the potassiums, the Ks, 2 on the left, 1 on the right. I will have to add an extra K there, balancing both sides. But looking at the oxygens, I only have 1 on the left and 2 on the right. So I'm going to have to create an extra oxygen on the left, but the K2 comes along for the ride as well, since those two are bonded. So now I've got 2 oxygens on the left and 2 oxygens on the right. Those are balanced, but I messed up my potassiums doing that, the Ks. So on the left we have 4, and on the right we have 2. So if I add 2 more Ks there, that should fix the problem. 4 on the left, 4 on the right, 2 oxygens on the left, 2 oxygens on the right. That is now balanced. And next to the symbols up top there, I would write in that we have 2 K2Os, 4 Ks, and then there's only one of those O2s. In this question, we have Na3PO4 plus KOH creates NaOH plus K3PO4. So we've got a bit more complicated one than the previous examples. So let's get started with the sodiums, Na. I've got 3 Nas in this molecule here compared to just 1 on the right side. So we need to create some more of the Nas. I'm going to create a copy of that molecule twice. So now I've got my 3 NAs compared to the 3 NAs on the left side. Moving on to the Ps, the phosphorus. We've got 1 in the center here and 1 in the center of this molecule here. The phosphoruses are balanced. Then moving on to oxygen. We have to be careful with this one because we've got 4 oxygens in this molecule here and 1 in this one here, creating 5 overall. And on the right side, we have 3 here and 4 here, creating 7 overall. So I do have 2 options for creating more oxygens. Either I can create another one of these molecules here, the Na3PO4, or I could create more of the KOH molecule and getting more oxygen from there. Going with KOH is the better route because if we went with the oxygen from Na3PO4, if I've recreated those oxygens there, we've now got 9 overall on this side, which is far more than the 7 over on the right side. So I'm going to have to do some more finagling with oxygens on this side in order to balance that out. But there is an easier way to achieve this. Instead, I'm going to go with copying the KOHs here until I have enough oxygens. So I've got 4 here plus 3 more here, comes up to 7 overall versus the 7 that we have on the right side. So the oxygens are now balanced. Conveniently enough, copying that molecule also gave me 3 Ks on the left side here, which balances out the 3 Ks on the right side. And also, that gave us 3 hydrogens, which balances out the 3 hydrogens on the right side as well. So overall, this is balanced. We've got 3 sodiums, NAs. We've got 7 oxygens, 1 phosphorus, and then 3 potassiums, and 3 hydrogens, 3 hydrogens. So the final answer for this would be 1 Na3PO4 plus 3 KOH creates 3 NaOH plus 1 K3PO4.